Video, I'm going to prove the Herserberg uncertainty principle. So most of us are familiar with this principle. So how do we actually prove it? If you have two or more waves, you superpose them. Say you have a wave function which is describing a wave, and then you add it with another wave function which is also describing a wave. You actually form wave packets. Now in the wave packet itself, if you extract the product of wave number and the change in position, it gives you 2 pi. But for the special case of Gaussian wave packet, it says that the product of these two, the minimum product of this, it gives you a half. So delta k delta x is equal to 1/2. So there is a proof you can check for the Gaussian wave packet. Now we will use this Gaussian wave packet. So Gaussian wave packet. Yeah. So we know that k is the wave number, and a wave number is equal to 2 pi over lambda, where lambda is the wavelength. For the case of de Broglie wavelength, we know that de Broglie wavelength is given by h over the momentum. That's the de Broglie wavelength. Now if we substitute this de Broglie wavelength in that expression, then we'll have our k being equal to 2 pi over, we substitute this into that, it will be h over p, which will be equal to 2 pi over h multiplied by p. Now for this case here, we know that this can be written as a h bar in terms of h bar. So h bar is actually equal to h over 2 pi. So for this one, since this one is below here, then it will be actually equal to h bar to the power -1 multiplied by p, which can be written as p over h bar. So we find that our wave number k is also equal to the momentum over h bar, and we know that if we take the change here, and then it will also be the change. So this is just equal to, if we take delta k, it will be equal to delta p over h bar. So yeah, something like that. We can generalize into that. So if we take this expression and now substitute it here, delta k is equal to delta p over h bar. We can take this one and substitute it there. So we'll have something like delta p over h bar multiplied by delta x is equal to 1/2. Yeah, is equal to 1/2. So you can rearrange by multiplying h bar both sides, then you have delta P delta X is equal to 1/2 multiplied by h bar, which just gives us the expression of that delta P delta X just equal to h bar over 2. So this is the Herserberg uncertainty principle, which states that you cannot measure both the momentum and position of the particle. So we cannot measure both with great accuracy. If the position is localized, that means the momentum will be infinite, and otherwise. So it's like that. Thank you.